Welcome to TLC tutorial videos. In this Windows skill review video, which is a three-part presentation, in the part one, we are going to discuss about the Windows file systems.
See the concepts. Okay, the very first thing when you are looking into the command line or any operating system, one of the key part of that operating system is the file system. Okay, so the file system mainly comprises of directories. They are like the green boxes here, and then files. And then why we are using an orange box here, it means this is the root for this file system. Okay, this is the root, and this is the purple ones are files, and then the green ones are directories. Okay, so most of your commands, the operands for your commands will be the resources. They are mainly directories and files. Whether you want to copy, move, or giving permissions, and then so on and so forth, or changing the directory, most of the time the operands will be mostly your directories and files. Okay, so and again, the commands are pretty straightforward. The key thing students or anyone struggles in the operating system, both in Linux and Windows command prompt, is how to build a path, okay, to reach a specific resource, either directory or files. So before we go into the deeper understanding of this, let's first understand this. This structure is an hierarchical structure, okay. It's again, you can see that this is root. I said, like, basically this is the root drive. So in the tree, we start from root and then we go all the way up. But here, we start from the root and then it goes all the way down. So this structure is nothing but, like, if this is the root and this is the stem of the tree, and then so you have leaves here, right? So it's very similar like that. So this is the root, right? Various branches are these directories, and leaves are nothing but files. Okay? So the analogy goes like a branch can contain another branch or a leaf, right? But a leaf cannot hold any other thing. That's the uh, lowermost level, right? You cannot go further down from the leaf because that's the last. Um, it's in the end of the system, right? So basically, files cannot contain another file or another directory. On the other hand, directories can contain another directory. In this case, you can see users contain your username, right? So I mean by what I mean by you here is your username. Okay. All right. So again, this like I mentioned, this is a hierarchical system, right? So basically, we have certain important relationships we need to identify here. So in this case, root is the grandparent, great grandparent for all the directories and files which are comprised under the root, right? So there is a parent-child relationship between the different levels of the directory, right? So if you consider this, this is like level 0, this is level 1, this is level 2, this is level 3, and then level 4. In level 5, we have two directories, and then in level 6, we have many directories, right? These are all in level 6 if you closely look at that. All right, so so there is a parent-child relationship exists between the levels, right? So in this case, for example, courses is a parent directory for system and programming directory. So on the other way you can say is system and programming are the children of courses directory. Okay, that's one key relationship you need to know. The other thing is siblings. Sibling means under programming, I have four children: Python, Java, C++, data. All are um, having a same parent programming, right? So these things are called siblings. So there is a subtle variation when we try to build a path. Siblings and children play a different role, and parent play a big role in relative paths. Okay, so we will look into that when we build the path. Okay, so again, this is an hierarchical relationship and they have multiple levels, right? The previous level, whatever the directories or anything it contains, the directories are nothing but immediate parent for the children's, like uh, whichever the directory comes under the parent directory, right? If the directories are, like if you have multiple children for a single parent, all those children are called siblings, and they should be in the same level, right? Then only if they are not in the, if they are in the different level, then they are not going to be parent-child relationship, right? So it's obvious. So in this case, again, I'm reiterating, Python, Java, C++, and data are all siblings to programming directory. All right. So with that, let's discuss about absolute path. So absolute path means it is a path which remains constant until otherwise you modify the file system structure. What do I mean by modifying the file system structure? Suppose you add a new directory or delete some directories, then you're changing this entire structure. That time absolute path may vary according to your modification. But for a given slice, right, for a given time period, you get the snapshot of this. If this is the file system, an absolute path to reach a particular resource will never change. It's going to be remain constant. That's why it's called absolute. Okay, it's not going to change. Okay, let's look at the example here. I want to build an absolute path to file1.txt resource. So file1.txt is here, and absolute path always starts from your root directory, right? So in Windows, our root, we will have multiple drives. Assume that we are talking about the C drive. So the root is C drive here. So if you follow the red line, right, the path, it actually creates an absolute path. So we start from C drive, and then we go to the child of the C drive users, and then you go to your user home directory. From there, its child is WakeTech, and WakeTech has a child courses. Courses has two children, system and programming, but um, the file one is in the path of programming, right? So that's why it goes to programming. From programming, I reach C++, and then from C++, I reach my file1.txt, right? So that's the absolute path for resource file1.txt. I think there is a one is missing here. I'll correct it. All right. So that's an absolute path. Then what is relative path? So often students get confused with relative path. So relative path means it's 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 a relative to some reference point. So that's the key thing you need to remember that. Okay. So it's relative to what? It's always relative to the current directory where you are placed. Okay. So suppose I am right now in my user's home directory, then whatever the path I build to reach any resources with respect to my user home directory, then it's relative to my home directory. You get the idea now? So to make it concrete, let's see an example. So before we go to the example, let's discuss about the relative path concept here, right? So there are a couple of key things you need to know. Okay. There is a relative path exists between my current directory and parent directory. Okay. So if I want to go from my current directory, if I want to move from my current directory to my parent directory, or if I want to reach to my parent directory, you need to use dot dot, two dots. Two dots represents the parent directory, and then the one single dot represents the current directory. I will demo this during my Windows demo time, so pay attention to that. So whenever you try to list a directory after you create a directory, it creates two entries. One is dot dot, that's the parent directory, reference to that, and one is dot that represents the current directory. Okay, so let's look at the example here. So I want to build a relative path from NAS 110. That's key. That means currently I am stationed right now here in NAS. Let me change my pen here. Okay. Right now I am here. Okay. From here, how can I build a path to reach table one dot dot? That's my, say for example, this is my destination. Okay, how can I reach that? So it's relative to NAS 110. You can see that, right? So again, there are a couple of key things I'll go through when I'm discussing here. So the first step is NAS 110 is in system, it's parent, but table one dot dot is in the lineage of programming, right? So in a way, it's in a parallel structure, okay? So the key thing is, if you're trying to access something like a sibling, you cannot hop from one sibling to another sibling. So you need to get a common parent. You need to first reach to the common parent. From there, you need to navigate yourself. Okay. So in this case, if you see that, so let's switch that. Like NAS 110 directory parent is system, and whereas the table one parent, I mean, it's in the lineage of programming, right? So system and programming are siblings, okay? So we need to find a common parent here. So how do we do that? First from NAS 110. So let's mark here, right? The first step. So the first step, I'll go to parent system, NAS 110 system. You can see the dark blue line, the path I traced here. Then again, they are still parallel, they are sibling, right? So I again go to the parent. Now I am here in courses, right? I am in courses. Now courses is a common parent, right? So from codes, I can go to programming, right? From programming, I can go to excuse me, from programming, I can go to data, right? So I'll go to data here, and then from data, I can access my table1 dot dat file. So that's why, so we reach first this dot dot is step number one. We go to system here, and then